All right, let's look at the homework 2.5, problem number 7. All right, so let's look at the options. All right, m of x is a polynomial. It's not. M of x is a rational function. It's not. There's a rational function inside. M of x is an exponential function. It's not. And m of x is a composition of functions that are continuous on the domain of m of x. All right, so you can see that it's a root function, and then 1 plus 9 over x is actually a rational function. So a choice would be that one. All right, then we want to find the domain. All right, so let's do that. All right, so only thing we need to be careful would be because of the square root. We have to make sure that, this guy, actually, there are two things we have to worry about. Let's see, that's not what I wanted to do. All right, so here, all right, first we have to make sure that this guy is greater than or equal to 0. All right, and also we can tend to forget here, since x is on the bottom here, so we have to make sure that x is not equal to 0, right? So let's work on that. So you have a 1 plus 9 over x is greater than or equal to 0, right? Then I'm going to actually rewrite this guy as, let's see, by taking a common denominator. So x is x over x, and then plus 9 over x, the same thing, is greater than 0, right? So what you do is we're going to draw a number line again. So draw a number line, right, x. And then we set the numerator equal to 0, so you get the negative 9. And put the set the denominator equal to 0, you're going to get 0, right? Then I'm going to indicate that at the negative 9, so the left-hand side is going to be 0. So we want the left-hand side is going to be greater than or equal to 0. So 0 is okay. All right, and then when x equals 0, since the denominator becomes 0, so the left-hand side is going to be undefined. So I'm going to just indicate by putting a UD for undefined. All right, then we can just try some sample numbers. So anything less than 9, so I'll just try x equals negative 10. Right, so if you plug in negative 10 for x, so negative 10 plus 9 is negative 1. Over negative 10, so negative divided by negative is positive, so you have a positive, which is good, which is what we want. How about between negative 9 and 0? So we can try x equals negative 1. Right, if you plug in negative 1, you have a negative 1 plus 9 is positive over negative 1, so it's going to be negative, which we do not want. Right, anything bigger than 0, so I'm going to try x equals 1. Right, 1 plus 9 is 10, over 1 is going to be positive. So this is what we want. So we want this part right here. So we want, this part right there. And then also we want this part right there. Right? Right, but we have to be a little bit careful here. Right, so negative 9 gives you 0, so this will be okay. So we want to include negative 9. Right, but we cannot include 0 because if x is 0, then denominator becomes 0. So we have to exclude 0. Right? So it looks like all we want is negative infinity all the way up to 9, including 9. Then starting from 0, but excluding 0, all the way to positive infinity. Right? So let's type it in. Alright, so the domain is negative infinity to negative 9. Include that, and then we need, let's see, set the notation union, and then start from 0 and all the way up. Alright, let's check the answer. Alright, I came back and looks like we got both parts correctly. Alright, that's it. I hope that this was clear.